Hello friends, welcome to my channel. Let's have a look at problem 360, Sort Transformed Array. In this video, we're going to share some solution formats based on a treatment, that is, specification of sorting key. So basically, this problem is a straightforward one. Here, our purpose is to give a thorough analysis for this problem. First, let's look at the problem statement. So given a sorted integer array called nums and three integers a, b, c, apply a quadratic function of the form fx equals ax squared plus bx plus c to each element nums I in the array, and then return the array in a sorted order. So here are two examples. So this is the output. So this example is rather straightforward to analyze. And for the constraints, first, the list nums has a length bounded above by 200 and non-empty, and the elements and a, b, c are in between 100 and negative 100 and positive 100. Notice that this range does include the possibility that a or b or c can be 0. And the third one, nums is sorted in ascending order. Notice that though nums is in ascending order, because the quadratic function in general is not monotone, so it does not mean the element after applied the function is still in a sorted order. So here is a follow-up. Could you solve it in the ON time? Yes, here we can, but we need some more coding lines. So here we're going to do a thorough analysis for this problem, because we meet this kind of problem typically in practice or in real world. So here is some observations. First, this constraint or assumption. So this is an important constraint. Basically, it means that the quadratic function format f can be a linear function or it can be a constant function. For example, if a is 0, then it's a linear function. If b also 0, then it's a constant function. Secondly, nums is sorted in ascending order. So this means that if a is 0, then we can directly use the original order or reverse order depending on b is greater than 0 or not, right? So if so if b is 0, so we can just return the original order if b is also greater than 0. So if b is 0 but also b is less than 0, we just need to return the reverse. So and lastly, if a and b are both 0, then f is a constant function, right? So this is the observations. Secondly, so for quadratic function, let's assume a is non-zero. We know that the symmetric axis is given by the vertical line, that is x equals negative b over 2a. So here I'm going to define this constant as x0. And then we can discuss the monotonicity, right? If a is greater than 0, in other words, the parabola is opened up, then the further a value x from x0, then the larger the function value. So otherwise, if a is less than 0, then the farther of a value x from x0, then the larger. Here I would take it this way: the smaller, in other words, the nearer to the x0, and then it means the smaller this absolute value, then the larger the function value, because in this case the opens is downwards. So in case you forget the elementary math, you could draw a picture to recall the above point. So for this problem, to make the code more modularized, we're going to define a sorting key, then sort the original list. Then we're going to apply list comprehension. And we think this route might be the point of this problem. So in order to make the solution ON, we could merge two sorted lists. So there's another one. This is also very naive or brute force. and that is to apply list comprehension, and then we do the sort. So this does the job. However, it might be not the core or essence of the problem. So with that said, before we do the coding, you can search Code-Yao in YouTube for more practices for coding problems or other algorithms. So with that said, I guess we are ready to do the analysis or do the coding. So here, first I'm writing a version v1. So this is the one I would like to emphasize. So it's sorting key, specify a sorting key. This is recommended by myself, right? For myself, recommended. So what we are going to do is to define a sorting key and write logic in this, and then apply list comprehension to the list. And first, let's define a sorting key. So actually, we use this trick quite a number of times in our channel. So here, what we are going to do is if A is not 0, right? So we know that if A is positive, then the further the x from the axis, the symmetric axis, the larger the value, right? So here, let me first get the axis. This is negative b over 2 times a, right? Then what we are going to do is to return this abs x minus axis. So this basically, if a is larger than 0. In other words, the smaller this value, the smaller the function, right? Otherwise, so we're going to return the negative on this one, x minus axis. So we shouldn't ignore or neglect the case that a equals 0. So in this case, we just need to return the b at times x plus c, because this function is a linear function. So with that done, so we define the function key, and then we're going to sort the nums according to this key above, sorting key. So because sorting key is a callable, so I can directly pass this as an argument to this sort function, sort method more precisely. And then we're going to do the return, do list comprehension, right? So we're going to apply the function a times x squared plus b times x plus c for x in nums. Because we have already sorted this nums, and then this list comprehension will return what we want. So this short code forms a solution format to this problem. So before we move forward, let's do a check. Yeah, it passes one example. Now let's look at the generic case. Yeah, it passes all the generic cases, all the cases. So this is the one solution. So I'm going to copy this part, the function signature and the annotation part, and then I'm going to mark this as v1. And then also we want to solve it in a brute force way. Let's see, we use a verbose way. So the verbose way is sort of, we don't care about anything else. We just, let's see, we just apply this function here. Let me copy this one. So we're going to set result equals to this. Then what we're going to do is to do a sort, and then we'll return the result. So this also, this way, it does the job. However, it might not catch the essence. Maybe it's just to catch the meaning for doing the coding. Anyway, let's do a check. Yeah, it passes a test. Then this is the generic case. So next, we want to make an effort to make the things on, because for this two solutions, basically sort is involved. The sort is generally an n logarithm n time complexity algorithm up to constant. Here n is the iterable length. So let me copy this one, and we'll write this as merge to list, sorted list, to sorted list. So this solution format is going to be longer in coding. However, its temp quality improved. So here, what we want to do is to make some discussions according to the function format and the distance of x from the axis. Then we're going to get two sorted lists in general, and then we merge that. Notice that the merge operation is also linear. So, and then overall we are going to have a linear algorithm, linear temp complexity algorithm. So for this purpose, let me first make some preparations. So get the length of this nonce list. Then we're going to make some discussions. First, if a equals 0, so this is the easier case. So in this case, the function is a linear function, right? So I'm going to discuss three cases. First, if b is greater than 0. So this linear function is an increasing function. So in this case, we are going to return b times x plus c for x in nums. This is very easy. Else, if b equals 0, so in this case, a is 0, b is 0. So this function maps every element to the constant c. So what we are going to do is to return c. The length is n. Otherwise, the b is less than 0. So what we are going to do is going to maybe let's write some details. So we can reverse the list and then do the return. Return the same thing here, because this is already yeah. So this is the further case. A is 0, so this is actually an easy case. So next, we're going to consider the case a is non-zero. So in this case, this function is a genuine quadratic function. For this, I'm going to first get the insertion point for the symmetric axis. So what we're going to do to get, so I'm going to use a better search, which is it's a logarithm temp complexity solution. It's faster than ON, right, in operation. So I'm going to use bisect left. So nums, because nums is in sorted order, so we can do this. B over 2 times A. So this gives us the insertion point. Notice that left to this index, all the elements is strictly less than this number. And then what we are going to do is to first, if idx equals n, it means that all the elements in the nums is less than this number. It means that it's all the elements is in the one side of the symmetric axis. Then if a is greater than 0, right? So the opens up for the parabola. Then in this case, the smaller, the larger. So what we're going to do is that we are going to so we're going to return nums next to so here let's see, I guess we have some so let me see. So in this problem, so if a is greater than 0, and so what we are going to do is to let's do this. So we can do, because the smaller the value, the larger corresponding to function value. Let's do this and then do list comprehension. Let's copy this part. So I'm going to write a times x squared plus bx. So this is a greater than 0 case. Otherwise, So the smaller, let's see, so the smaller the larger. So we just need to directly return this one. We do not need to reverse this part. So let's recall. So if idx equals m, it means all the elements in the nums is in the left side of the symmetric axis. Then if a is greater than 0, so then we need to reverse this nums. The reason is that the smaller the x, the larger the corresponding value. But we need to return the values from small to large. So we do a reverse, and then we do a list comprehension. If a is less than 0, so in this case, the parabola is opens downwards, and then the smaller the x, the smaller the value. So we're going to just return this part. So this is the case for idx equals m, right? And we discussed the case that a greater than 0 and a less than 0. And then consider other case, else if idx equals 0. So in this case, what we're going to do actually is that all the elements are to the right of the symmetric axis. So in this case, if a is greater than 0, right, then it opens up. Then the smaller the smaller x corresponding to smaller value. So we just need to return this. And otherwise, so we do a reverse, and then we return all the elements. So this is the case idx equals 0. These are the two extreme cases. And then otherwise, so we're going to split nums into two parts. So here we're going to use merge two sorted lists. So first, if a is greater than 0. So in this case, the left part I'm going to use as this, nums up to idx. But because it's in the left, and the smaller value corresponding to larger function value, we are going to use a reverse. And then we're going to set the right to be nums idx onwards, right? So otherwise, if a is less than 0, so we're going to set left to be nums idx, because if it downwards, the smaller value corresponding to smaller function value. For the right, we are going to use a reverse, idx onwards and idx reverse. So this is the to set left and right. And then what we're going to do here is to use list comprehension. For left, so we're going to get, I'm going to directly use this. Left equals this list comprehension for x in left. And then I'm going to copy this part to be right. And this is also right. And then both left and right are in sorted order. Then what we are going to do is to join them to a sorted list. So this is just nothing but a standard task of merge to sorted list. So here I'm going to do this. This is the result. And then what we're going to do, notice that this left has length given by the index idx. This right will be, the length will be n minus index. Then the while loop will be like this. First I'm going to set I equals j equals 0. And then while I is less than idx and j less than n minus idx, the length, right? Then we're going to check if left I less than or equal to right j. And then the result will append left I. Then increment I by 1. Otherwise, so we're going to do append right j. and then J incremented by 1. So after this while loop, one of the list should be empty. There's possibility that the other is not empty. Then we're going to extend, right? So if I less than idx, then what we're going to do, result extend. So left, so from the I onwards. If J is less than n minus idx, so result will be extend to right J onwards. And then we're going to get a combined list. So we're going to return results. So this is the third solution format. It's sort of running long, but let's do a check for this one. We're going to change this one to be V2, and this is V1, V2. Now let's do the check. Yeah, it passes the first example. Now let's look at the generic case. Yeah, it passes all the cases. So here I suspect that if we copy this one, if we can combine all the discussions in the, let's change this one to be V3. So here for this, do we need this discussion here, idx equals n or here? So let's so this is the, basically we are worrying about the out of range index problem, but let me delete this first. So we comment out, and then we're going to move this one here, or just for a test. So we can do this. You can do this in one go. Yeah, let's do a check first. So in other words, we just split directly. Yeah, it does the job. So this will shorten the code. So basically, we discussed the case for a equals 0, and then we discuss the case a does not equal to 0, and then we get the splitting index. Then we split the nums and also do necessary reverse, and then we're going to merge two sorted lists to get the result. So with that done, I guess that's about it for this this problem. So here we demonstrate three formats of solution. So the first one is the one I like very much. So we use a sorting key. So we use this trick to do list comprehension. The second one is more direct and verbose. And the third one, basically, our intention is to make the code O of n. However, the extra work is that the coding part or the code itself is longer in some sense. But still they are actually stacked together some routine task. With that said, I guess that's about it for this video. So thank you.